3 videos ago, I made a video titled Never Was about a startup company idea that I had that never became much of anything. Today, I want to talk about another idea that probably never was a good idea in the first place. Before we dive into the idea itself, let's cover a few basics first. First and foremost, I want to talk about the difference between humans and computers. Obviously, there are a lot, but I think respectively, we're each good at different things. I've long argued that human-like robots are interesting for research, but not much more. The reality is that humans are one size fits all thanks to evolution. We are only ourselves, and we have to be able to tackle an incredible range of problems. And so we're generalists. But if we know anything about one size fits all sweatpants, we know that while that solves the problem of pantsing us,
You keep using the word. I don't think it means what you think it means.
something tailor-made does a much better job and looks a lot better. I think of robots the same way. Robots don't have to be built for all purposes all at once. As an example, if I wanted a robot to help me get around the city, I would not build a human-like robot and then have it carry me piggyback style wherever I want to go, as entertaining as that might be. Instead, I might create a self-driving car to get me from point A to point B. To this end, computers and robots have a huge advantage over us, which is that they can be purpose-built to a particular problem that we're trying to solve in a way that humans simply can't. Beyond that, though, humans are particularly bad at precision and repeatability. You ask a person to draw a picture once, and they'll do a good job. You ask them to draw the same picture 5 times, and you'll get 5 pictures with a great deal of variance. Whereas with a computer, you ask it to reproduce the same image 100 times, and you will get 100 nearly identical versions of that image. The second major concept to talk about is information density. And what I mean by that is the amount of stuff or information that we can fit in a particular space. And for the most part, information density for people exists within a very narrow band. The old saying, a picture is worth 1,000 words, kind of covers the two main forms of information transference that people have at our disposal. We have words and we have pictures. And in different contexts, they potentially have different densities. We can communicate more information with a picture than words in that particular example. But generally speaking, we don't go far outside of that band. We express ourselves with the tools that we have at our disposal that we, as the generalists that we are, find accessible and intuitive for doing what it is we need to do and communicating what it is we need to communicate. That's not to say that sometimes humans can't play in the space of information density. We can say, take this text message and replace a few of the words with emojis, and suddenly we have a message that is smaller but communicates the same amount of stuff, so is by its nature information dense. But computers operate in the information density space on an entirely different level from what humans can even imagine. As an example, this particular video on YouTube in its URL has an 11-character string base 64 encoded. And that is a unique identifier that a computer can look at and recognize that that particular string of 11 characters correlates to exactly this video that lives somewhere on a bunch of YouTube servers. And what base 64 encoded means is that each of those 11 characters, or those 11 slots, can have one of 64 options. And when you do the math on that, That means that there are 73 quadrillion combinations of those 11 characters, base 64 encoded. To say the least, that is some intensely dense information, but you don't see people wandering around remembering 11 character sequences in order to tell one another what their favorite YouTube videos are. And that's because people struggle with precision and recall in ways that computers generally don't. Those 11 characters for a computer are incredibly precise and reference something very specific, but to humans, changing one of those characters slightly barely registers at all to them. It seems like the same sequence, but could point at something wildly different. Another great example of this is barcodes and QR codes. In the simplest form, barcodes are just a set of spaces that are either filled in or not filled in. A human can't look at that and discern any meaningful information from it, but a computer has the ability to look at it and immediately recognize a unique product identifier embedded within it. QR codes, by extension, are basically just two-dimensional barcodes. So instead of having a line of empty spaces, now you have a grid of empty squares that are either full or not full. QR codes also can hold significantly more information than barcodes. As an example, this QR code here contains the entirety of Edgar Allan Poe's A Telltale Heart. It's perfect for a computer to read. The computer has no problem either reading it or generating it because computers are precise in that particular way. But if I had to read A Telltale Heart by looking at that QR code or had to transcribe A Telltale Heart into that QR code, I'd be in for a lot of pain and suffering. Glyphs was the working title for a project that was meant to marry human generatable glyphs with information dense representations, essentially creating human drawable QR codes. The idea being that QR codes are not particularly aesthetically pleasing or memorable, and you can't draw them yourself. So you end up maybe carrying around a pocket full of stickers in order to be able to get QR codes out in the rest of the world. And this challenge of creating a drawable, memorable, information-dense representation raised some interesting questions. Specifically, what are people good at? We know that people aren't good at filling a grid very precisely and memorizing exactly what, say, a QR code looks like. But there's an interesting question of what are the things that people can remember and can we create enough permutations from them? So as an example, we're pretty good at drawing a triangle versus a square. We're not accidentally going to draw a circle when we mean to draw a triangle. We're reasonably good at drawing lines of relative length. Like I could draw a line and I could draw a line half the length. You're not going to find me drawing a line that is exactly 27% as long as another line. We're reasonably good at angles. So I think it would be reasonable to ask someone to draw a right angle, an acute angle, or an obtuse angle. We're good at relative things. One circle is larger than another circle. One circle is inside another circle. Two circles overlap. We could probably also identify positions on shapes reasonably well, like the upper right corner of a square. And the question then becomes, can we find enough of these things that people are good at expressing and create enough permutations to create something highly information dense, while at the same time leveraging computer vision to recognize those features and those relationships in a way that is tolerant to human imprecision, but still encodes a great deal of information into the thing that is being drawn. The consensus from my colleagues was probably not, and even if we could, does anyone really want to draw QR codes? And those are both relatively fair criticisms. I think that my colleagues were probably right on this one. But this remains a fascinating idea, even if not one that has any business value. It's highly unlikely that someday people will be taken by the idea of being able to draw a picture and have their friends be able to scan it on their phone and be brought to a particular website. It might offer up new potential for rickrolling people, but that might be the extent of it. But I think the challenge is fascinating. The mental exercise of asking this question, how information dense can people be expected to remember and draw, is an interesting question. And I do think that there could be a future in which cool looking logos also innately had information encoded into them. That's a whole different discipline of computer science, kind of hiding information inside of other larger bodies of information, which I think is really fascinating. But, anyways, this was the weird idea. It probably never was a good idea, but I think it was at least an interesting one to talk about. So for now, I hope you have a wonderful rest of your week, and I'll see you in the next one. Bye. Not a potamus. Ponderous.